Phase shift keying is basically a shift in phase. Now we have seen that when it goes from 0 to 1 and 1 to 0, a shift of phase is happened. Now here what we do, the carrier is same, only a shift is happening. Now it's not necessary it should be 180-degree, it can be 45-degree, it can be 60-degree, it can be any number or any degree which is different from the first one. So naturally a shift will happen. So like here, if you see the example, the shift is purely 180-degree. Because of that, what is happening, it's absolutely reverse. Okay, but when the degrees are different, say for 90-degree the look will be different, 45-degree the look will be entirely different. So as again I repeat, it's not necessary it should be on always 180-degree. It can be any angle that you can give, because our main aim is that in the same bandwidth, if you see here, in the same bandwidth we want to send the entire signal. If you see, the bandwidth is same, but what we want is more number of signals can be sent by just by little phase. Like if I'm sending 5 signals, right, then each signal is, one is say 90-degree, one is say 45-degree, one is say 60-degree, one is say 75-degree, one is 180-degree. So just by changing the phase we can send many signals at a time in the same bandwidth. That is the advantage of phase shift key. And in digital communication, FSK and PSK is generally preferred. So now how it has been done? Again, input data is being given, which is already in the digital form. And then a carrier frequency is been there. In balance modulator, the phase shift is happening because every binary sequence, like 00 is having a one sequence. Say it starts on 0 degree. 01 says it starts with 45-degree. Say 10 starts with 90-degree, and 11 starts with say 75 degrees. So you can see by sending the by using these codes, what we are sending many signals at a time just with the phase shift. So that is an advantage that we have with phase shift, that many signals can be sent between with the phase reversal of 0 to 180-degree. So that is one thing. Now here also they are mentioning that sine wave carrier takes 4 phase reversals: 0 degree, 90-degree, 180 and 270-degree. Also these techniques can further be merged with PSK, FSK and many more combinations. So how it is working here, we will take with 2 bits, that is 0 and 1. So we are taking, say, the voltage of the first one. Now again, remember the voltage always remains same. What is changing is phase shift. So because of that, they have shown minus sign here. Because the phase shift here, if it is 2 pi ft plus 0, here it is coming as 2 pi fct plus 180-degree. And if you talk in terms of sinusoidal waves, then it becomes minus. So for cos, it remains the reverse. For 90, it remains same, whereas for 180, it reverses. Same way for sine, it gets reversed. So naturally, with this reverse, you can see the difference between V1 and V2. Now here, this is what we have discussed, that various signals can be sent. Then for the block down here, for the block diagram, it has been said that phase balance modulator is playing a very important role for merging your carrier and digital signal. Then QPSK, if you are sending, like same thing that we discussed just now, that various data can be shared with the help of different bits that are being used. Now here they have shown different phase angles. So one is for 00, one is for 01, 10 and 11. So different phase with the like it, you can say like a spiral, different signals are going together in the same bandwidth. That is advantage of PSK, that bandwidth doesn't widen too much. For FSK, the bandwidth widens because you are using different frequencies. But for PSK, the bandwidth is not as wide as FSK. So that is a very good advantage that we are having.